And the last thing that we are going to cover is the so-called Simpson's paradox. So basically, Simpson's paradox, it tells us that we should be careful with association rule mining. So here is an example. I'm going to simulate some data, y and x, and I'm going to fit a linear regression. So y is going to be a linear function of x, right? And notice that when I fit a linear regression, the coefficient at x is negative, right? So it means that the overall trend is decreasing. So the bigger values of x means lower values of y. Well, however, if we plot the data that I simulated, then we see that there are two different groups, and the trend is positive in each group. Right? So there is the first group, there is the second group, and the trend is positive. So imagine that if these groups are like male and female, then within males we have a increasing trend, within females we have a decreasing trend, but because there is a difference between groups, the overall trend that we observe is decreasing. And it is possible. It is, of course, possible. So here is an example of how it works with association rules, right? So this is a table of sales based on customer habits. I'm not going to do a complicated, detailed analysis. So it's just that people who buy or not buy diapers and buy or not buy beer. And by the way, so we are going to treat the absence of beer as an item and the absence of diapers as an item, right? So we are going to look at rules of the type beer implies diapers, right? So confidence of the rule beer implies diapers is as follows. So how many customers are there who buy beer and diapers together? It's 99. How many customers are there who only buy beer? 99 plus 81. So computing this, we get 0.55. So confidence of the rule, the absence of beer implies diapers. So if there is no beer, then diapers. So here, so imagine that for someone who did not buy a beer, I'm going to add like imaginary item labeled no beer, right? So then I can still run association analysis with this imaginary item. So confidence of the rule, the absence of beer implies diapers is, well, because of the same idea. So how many transactions are there where they bought no beer but bought diapers? No beer and diapers, so 54. How many transactions are there where they did not buy beer? 66 plus 54. And this is 0.45. Right? And based on this, we see that, well, customers who buy beer are more likely to buy diapers than customers who do not buy beer, right? Because the confidence of the rule beer implies diapers is just bigger than the confidence of the rule no beer implies diapers. However, this happens because there is a confounding variable, something unobserved, right? So in fact, there is this unobserved variable, customer group. So, and our customers are either students or adults. And it happened that they have different customer habits. And of course, students are probably less likely to buy diapers than adults. And then now if we are going to look at the confidence of the rule beer implies diapers just for students, right? So we are looking just at the student portion of this table, right? So how many transactions are there where they bought beer and diapers together? Just one. So how many transactions are there where a student bought beer? Is 1 plus 9. So this is 0.1. Okay, now confidence of the rule no beer implies diapers for students. Okay, so how many transactions are there where they bought no beer but diapers? No beer but diapers is 4. How many transactions are there where they bought no beer, well, and probably bought or did not buy diapers is 4 plus 30. Right? And it seems that for students, since the confidence of the second rule is higher, so it means that the students who buy beer are less likely to buy diapers than students who do not buy beer. Or students who do not buy beer are more likely to buy diapers. Okay, now let us look at adults, right? So confidence of the rule beer implies diapers for adults. Now we're looking for adults. So how many customers are there? So how many adults are there who buy beer and diapers together? So beer and diapers together, 98. So 98 plus how many customers are there who, adult customers are there who buy just beer is 98 plus beer but no diapers, 72. And it is this number. Okay, so confidence of the rule, no beer implies diapers. So no beer implies diapers. No beer and diapers, 50 divided by 50 plus no beer and no diapers, 36. And it is this number. And again, the second number is bigger than the first number. So it means that, well, it seems that adults who buy beer are less likely to buy diapers than adults who do not buy beer. And this is Simpson's paradox, is that when seemingly we have some trend in the data, but if we include some unobserved variable into consideration, then the trend disappears or even sometimes even reverses. Okay, so this was the last topic in this lecture and the last topic in this course.